Alright, so I got tired of waiting for that part, the attenuator from Greece, so I wised up and I did what I should have done before I even ordered the part, and I pulled the attenuator out of the channel 1, so you can see it's out of here, and I swapped it with channel 2. So here they are out of the board here, and it was a lot easier than I thought it would be because they're not soldered, they're actually socketed. So these are all sockets here, and I wish I would have known that. I would have swapped it before I even ordered the part, but swapping them did nothing. Channel 1 still has the issue, and channel 2 still looks good. So it's not the attenuator. I'm glad I checked because I would have waited the 1 to 2 to 3 weeks for that attenuator to come in, only to find out that it wouldn't fix the issue. So I did some more digging. I went back to the schematic, and again, the two areas of concern were the pin 5 and pin 8. That's what they call them. It still looks like pin 1 and pin 6 and pin 9 to me. But then, as I discussed earlier, there certainly isn't anything, at least on this schematic, other than this 10x attenuator. So I thought that should be the issue. So I looked at the board a little bit closer, and I realized that the board and this schematic don't match up completely. So I don't remember if I mentioned it earlier, but this schematic is actually the 2215A. And again, I am working on the 2213A. The reason I have this schematic is because the 2213A schematic does not exist, or I can't find it. I did have the 2213 schematic, but that attenuator board is completely different. And so after looking online, I was told that the 2215A has very similar, if not identical, schematics, other than a few minor differences. This must be one of the differences. So I'm no longer going to trust the schematic. And I did some poking around on the board. And so first of all, on the schematic, it doesn't show you any of these components here. So pin 8 or pin 9, you know, they call it pin 8 in this schematic. I think it's the 9th pin. Comes to this resistor here. Zoom in here. So it comes to this resistor. It's also, you'll see it hits this capacitor here, and there's another resistor right here. It's tough to see, and then it comes to this resistor. Through this resistor, there's another resistor right here that's tough to see, and then comes here into the middle, which actually leads to another resistor on the back of the board, and then this is part of our attenuator. So anyway, I checked all these resistors. They're just fine. They also match up with channel 2's resistors as well. So I did they're all in a series. I measured the resistance. They all look to be fine. The capacitor seems to be fine. I highly doubt that failed. And so I did a little more continuity checking. I said earlier that I don't think it's a connection issue, but after digging some more, I've changed my mind. So let me get the light here so you can see. Open the camera. It's a little better. Okay. See if I can remember what I was looking at. Go some papers. So let's see. I'm in the correct range right now. So you can see pin of interest right here is this one. So the one directly behind this capacitor. So you can see there's two pins on this little fork here, and there you can't see it, but behind here they're actually attached. So they're continuous. And you can tell when I put them together, obviously you can't see what I'm probing, but this is a continuous fork here. So these two pins, they look separate here, but they're actually continuous. So the pin on the right of this fork leads to the capacitor, this resistor, and this resistor's line in series here. So I checked continuity there, and it's there. But when I check from the other leg, so the left pin of that fork over here, I get no continuity. Okay, and I'm on that pin. And so if we move up to channel 2, I'm going to do the same thing in the same position just to verify. So again, I'm going from the left pin to the right pin. You can see we have continuity. And so what this means is Now you can't tell what I'm doing, but I think now I've definitely found the issue. And you're not really going to be able to see it, so I'll just describe it. This right pin here on the fork, I'm going to put my probe ever so gently on there and then measure to this resistor. Again, this should make contact, and it's not. Now if I push down on this pin, you can hear the contact, and if I release it, you can hear there's no contact. So if I put a little bit more pressure on there, there is continuity. So the issue is that pin is not making complete contact with the board. And so that's what's causing our issue. So the question is, what's the best way to fix that? I mean, to do it 100% right would be to pull this attenuator board out again, which means, you know, disassembling. It's not too big of a deal. I did that. And then pulling this whole rotor switch off to gain access to all these pins, and then probably just bending that pin in place. But I'm going to attempt to bypass that and just try and bend this pin ever so slightly so that it's making good contact. It may work. If it doesn't, I'll pull the board out. I'll be back either way and let you know what I found. I attempted to bend the fork while the switch was still installed on the board. It didn't work. I broke one of the tongs off, one of the pins off. So I pulled the switch out. It was actually easier than I thought. I wish I would have done it at the beginning. It's just in this little modular fashion here. And there's just actually 2 screws on the bottom and it pulls right out. So I wish I would have done that originally. So as I said, I broke one of the tongs off. I was able to get this fixed. I got very, very lucky. So what I did, you can see this middle pin here with the solder. So it's not the prettiest thing, but I'm going to leave it because this is the only way it's going to work. And if I try and clean this up and make it look even better, I know I'm going to screw it up again. So I got very lucky in that 2 of these pins, you can see all these little tongs here. There's actually 2 sets, and they overlap. You know, when they're sitting on top of each other, they overlap, right? And I compared with the other switch, and if you see the 2 prongs on the right, as I go the entire length of the dial, they never make contact with the board. They're always in the raised position, and actually, this switch isn't used, so it must be used on another, maybe another model type or something like that. The 3rd pin over there is always making contact, and the 2 on the right are never making contact. So the 2 on the right aren't used. So what I did was I clipped both of them off, and I needed both of them because I melted the first one. So if you look closely at these, you can see it's just one metal strip with the, you know, metal strip coming out of each, but then you have these little tongs coming out, and they're attached with this little piece of plastic. And so what I did was I cut one of these off. I attempted to solder it on here, and hold it on there too long and this plastic starts to melt. That's exactly what happened on the first one. So I got a little too ambitious. The second one I got lucky and it stayed. I think it looks pretty good. It's not perfect, but it's definitely on there. I think the distance is right, and I think this is going to work. So it's hard to tell if it's bent into place right now. I kind of bent it down just to make sure there's going to be enough tension. So I'll reinstall it and we'll see if it works. After removing that strip, I don't know, 5, 6, 7 times to try and bend those pins into place, I finally came up with a solution, which was to add a little bit of solder to the pads, and that worked like a charm. So I have the board reinstalled, and everything, I believe, is connected up correctly. Everything's turning nicely, and we're ready to test it out. So here we go. Alright, I'm plugged in. Cue the magic smoke in 3, 2, 1. Alright. We're fired up. A lot of noise there. That doesn't look good. That's not a good start, is it? Yeah, that's not a good start. that could be the solder job on the resistor. So there's a resistor between this, the input pin and the actual attenuator board. And every time I removed that board, I had to desolder and then upon install resolder, and that thing got pretty worn. So maybe that has something to do with it. But let's see if we have a signal anyway. So we're in the one. Oh, we got nothing. That's no good. Let's see if we got something here. Oh no, it's even worse. It's even worse. What happened? Anything in the 5? Nothing. And now I don't have a signal at all. Anywhere. It's just super noisy. You can see that. Something's not right there. Figured out why I wasn't getting any signal on channel 1, and my previous assessment that the 2 pins on the right here were unused was incorrect. So it is true that the volts per division knob does not couple to this rotor here. It couples to this rotor. But what does couple to this is the DC coupling knob. And so there's 3 set points there, right? Ground, AC, and DC coupling. And so all 3 of these pins are used, 1 set for each, you know. So you can see on channel 2, the leftmost pin is down and enabled. That's the one that so that's why I assumed the other 2 aren't used. But this is in the ground mode. So what I did basically was I removed any chance of DC or AC coupling. So you can see it's hard to move it, but I should be able to move it by hand. And it's hard for you to see there, but, well, no, that didn't move. There we go. Now, the leftmost pin is up, and the 2 on the right are down. And that, I believe, is the AC coupling. And then if you go one further the other way, you get DC coupling. But anyway, that's the problem. So what do I have to do? I mean, I was out of luck anyway, because I didn't have one of these pins, so I had to do what I could to try and get it fixed. But I do need the entire strip here. So again, there's 2 strips overlapping here, and I do need every pin on each strip. So how do I fix that? Well, I cut these back, as you can probably see. I'm going to take these strips out again anyway. Sorry about that. You can see I cut the 2 pins back right here. Where am I at? Right in here. I cut them basically all the way back to the base of the strip. So it's going to be pretty tough to tie anything onto there to make a new strip and to make it work. It's not going to work. So I looked online and I found this exact board. Well, I should say it's not this exact board. It's you can see the part number here. Right up here, 6708267-02. I found a 0-01, and that's for a 2232 model, something like that, 2233. This is the 2213. It looks identical. Obviously, there could be some differences component-wise, but all I had to do was match these up. All of these nodes here on both rotor shafts match up identically. So I'm very confident that the strips are going to be identical. And so with that board, I'll have 4 spare strips. I only need 1. But before I go ahead and buy that, it's not too expensive. So just the board, it's definitely worth buying that if I don't have any other problems with this scope. So what I'm going to do first is verify that I fixed the original issue of basically no signal on the 0.5, 0.2, and 0.1 volts per division. To verify I fixed that, I'm going to swap the strips between these 2 so that this is making good contact over here. And then we'll check out the signal on channel 1. If it looks good, I'm going to buy this board and then we should be all good. So I'll swap the strips and I'll be back. Alright, strips are swapped. Channel 2's strips up here, as you can see by the missing pins here and the amended pin there, and then the nice clean strips here now on channel 1. Okay, we're all swapped, ready to reinstall and test. I installed the board. I'm not even going to bother putting channel 2's knob in there because I'm just going to have to remove the board anyway when I get the new strips in. But I wanted to test channel 1 to make sure A, that we have a signal back, and B, that we resolve the original issue of no signal on 0.5, 0.2, 0.1 volts per division. So here we go. I'm on channel 1. I'm at 1 volt, and we still have our signal there. Good. So we resolved that issue. Now here's the moment of truth. Is it going to work in this range, starting at 0.5? Yes, got it. 0.2, got it. 0.1, all right. That's good news. So we resolved the original issue. Again, that was the fork on the strip not making good contact. I think it was number 6. So I just added a little solder to the board there so that it would be raised and make it easier for the fork to make contact. So that's good. I'm definitely going to order that board. I'll replace the strips on channel 2, and we'll test it then. But everything's looking good so far. Pretty excited. I finally got the new board in from Greece, and it looks nearly identical to the old board. I'm very confident that the strips are going to be the same, so I'm going to go ahead and remove these strips, and I'll just replace both sets while I'm at it. I'll also remove the solder that I added to these solder pads here. I shouldn't need that at all. The new strips should be able to take care of it. And we'll see where we're at after that. I'll be back after I reinstall it. Alright, moment of truth. Time to turn it on and see if we resolved our issue. I'll start with channel 1. And there's our signal. I'm at 5 volts per division. Didn't have an issue here before. Let's make sure we still don't. Nope, it's still there. Let's go to 2 volts per division. Still there. 1 volt. Looks nice. Half a volt. Still looks nice. Good. So this is where we had our initial issue, and we have it. Turn that down a little bit so you can see it better. Let's go to 0.2 volts per division. Still looks good. And 0.1. Good. So that scale is it's good, and we're good all the way through. Excellent. Let's try 0.2, or excuse me, channel 2. I did swap the strip from channel 1 to channel 2, and then we had our issue on channel 2, so we'll have to make sure that that's resolved now. And we'll start off at 0.5 or 5 volts per division. Good, still there. And 2's good, and 1's good, and good. 0.5 looks really nice. 0.2 looks really nice. 0.1 looks very nice. Good. And we'll keep going. Yeah, it's all the way there. Good. It's bright. Awesome. So that's fixed. I'll probably have to do a little bit of tweaking. If you noticed on channel 1, initial spike up, front half of that waveform. You can see that. A little bit of overshoot on up and down. So that may be a little bit of tweaking. You know, I did mess with a lot of the potentiometers on that board, so I may have to go through the service manual and make some adjustments to those again to make sure that that overshoot is gone. Thought I'd show you. I just went off a hunch that the 2 potentiometers that I was adjusting on the, actually they're 2 capacitors, on the attenuator that I originally replaced. I just started on one of those and swatch. That overshoot goes away. So there we go. So now it looks really good. Now I'll throw a sine wave on there, maybe a 5 kilohertz, and we'll see how it looks. Alright, I cleaned the scope up really well. Cleaned up nicely, actually. Was able to get most of the gunk off, the stickers. There was a big yellow splotch up there that I was able to remove for the most part. and I have them hooked up to a rolling audio signal, so it's gonna change from 20 hertz to 20 kilohertz. I thought that'd be kind of interesting to watch. They both look really clean. I'm sure it'll have trouble triggering at some point based on the time scale, so I'll have to adjust that. But so we're at 4 kilohertz right now. It's looking pretty good. Change that. You can see it's always shifting. But it's looking really good. I'm very happy with it. Everything seems to be working really well. So I'm going to call this one fixed. And I'll just let this one play out up to 20 kilohertz. We'll see if it'll make it. Probably have to increase the... it's still going. See, the amplitude is decreasing as well, and it made it to 20 kilohertz. Looked pretty good. Alright, that's it. Another scope fixed. I got another one coming, a TDS 420A, I believe. That won't power on, so I'm excited to start working on that. It should be in this week, so stay tuned for that, and thanks for watching. We'll see you on the next one.